So the moral of the story then is that salamanders, if we go back to our initial survey of regenerative processes in the animal kingdom, can actually use local cells to replace damaged tissue. So if you cut off the end of a salamander's limb, you can regenerate it. With mammals, we're basically looking at a slightly less efficient arrangement whereby circulating cells can have some effect along with local cells. But to really make that a clinically relevant phenomenon, we're definitely going to have to resort to some tricks. And in this case, we used a genetic trick in which we used growth factors. So then in conclusion, tomorrow I'll be able to tell you a bit more about the mechanisms that we envision to identify the factors that we'll need in order to augment the extraordinary capacity of stem cells to do a better job for us in our own bodies. And I'll stop there and take questions. Oh, forget it. Sorry.
You talked earlier about how the liver is able to regenerate and heal itself. And then there's also the case of liver cancer. Is it possible to inject stem cells from a healthy donor into livers and then kind of reverse the effects of liver cancer?
Well, it's a great idea, and in fact liver transplants have been very successful precisely because of the fact that a diseased liver can be literally completely replaced with a small portion of a healthy one, and it grows right back to the full-sized liver in the recipient. The problem with liver cancer is that cancer itself is a very nasty disease because it grows even from a single cell. And so it's unlikely that you'd want to leave any cancer in the body. You'd want to try to remove it before you try to regrow the liver. But the concept of regeneration of the liver is one that's been well used and is an extremely successful operation for many people who have damaged liver. Yes?
Hi,
this one I can do. Look at that. Practice.
And she talked about regenerating the liver. And if we have, some cells in our bone marrow, and those bone marrow cells, then how come as we age, we get shorter? Why do we age if we're able to regenerate ourselves?
Why do we age if we're able to regenerate ourselves? It's a great question, and if you promise to come tomorrow, I'll answer it for you. I have a whole talk on aging, and it will take me too long to do it now. But you get a t-shirt because you're close, and I feel like I can probably pull it off. Okay, notice I can't just take you in the front because it's not fair. Okay, I'll go for the fellow in black who thought I was going to ask him a question at the very end.
Okay. I was just curious, how far can you cut, how far up the limb of a newt can you cut and it will still regenerate? Can you cut all the way? I mean, I guess I'm a bad example, but if you cut off above the shoulder, would it still regenerate, or how far? Yeah.
That's a very good question. I have never cut the arm off a newt, but I presume that you can get pretty much as close to the trunk as you can get a scissors, and it still will regenerate. If you would then go in with a hammer and chisel and take out its whole shoulder bone, I suspect that we might get something a little less nice than a full limb. But I think your question is very good. How much information do you need to start with to regenerate an entire limb? And I think that the issue is very, very pertinent because obviously there must be something that tells the organism that I am a shoulder and then I am a limb. But I don't think that there's any boundary line there. It's probably just more of a practical issue of how you could actually cut that limb off. So you can get pretty close to the bone, as it were, and still regenerate. The lady in white.
If you cut off the arm of a newt or a salamander or whatever, will it grow back the same exact arm? If it had a marking on it, will it grow back with the same marking and everything?
That's a wonderful question. The answer is that you do lose some of the actual marcation on the limb. And we believe that's because some of the cells that end up in the limb to make this demarcation originate from someplace other than the limb. And so, in fact, you may not get the exact pattern back. The lady, you know what? I'm forgetting about the t-shirts. But this is really tough. Can I do relays? Because otherwise it's not going to work. I'll throw it halfway there. And now for you, whee! At her feet. Okay, the lady in pink.
I was wondering if you were to take a newt and cut off 2 limbs at the exact same time, once at the wrist and then one maybe at the elbow, would it focus on the more serious injury, or would it regrow the same 2 at the time? Or would it maybe the CD59, would it get them mixed up, which one was cut at the wrist and which one at the elbow?
It's a great question. The answer is that these events are local, and so the limb that needed to grow back just a hand would grow back the hand. The limb that needed to grow back the whole thing would grow back the whole thing. It appears that these are local signals, and therefore they don't actually get mixed up across the body. It's a very, the CD59 molecule is actually sitting on the surface of the cells within the limb. So it's as if the surface of the cells were just a more intense pink up here and less intense down here. So it's an intrinsic capacity to read your zip code from your local information, rather than some guy coming around and telling you. And I'm sorry, got to get rid of the t-shirt. I'm getting better at this, but I'm afraid we've got to stop. Time is up. And thank you all for your attention, and we'll see you in the morning.
Thank you, Nadia. And there were plenty of questions left, and obviously the people out there watching this on a DVD in the future or on the web right now can't ask questions right here, but we have a mechanism to answer questions without fear of flying t-shirts. And that's found on that website, biointeractive.org, a feature called Ask a Scientist. And that's worth looking at. If you have a question on this or other topics, you can send it into that site. Our volunteer scientists will answer it. We'll answer you directly, and if it's a question that we feel is worthwhile, we'll even post the question and answer. And those are archived, so it's a very interesting resource for other questions in any case. So thank you.
This program was brought to you by the Howard Hughes Medical Institute. For more information or to order DVDs of the lectures, go to www.holidaylectures.org/rc.